Today we're going to talk about the intricacies of smart contracting through the blockchain. We're very delighted to have here Oleksii Konashevych, who's here. He's a visiting PhD student being supervised by one of our colleagues here at the RMIT Blockchain Innovation Hub, Professor Marta Barcel from the RMIT Graduate School of Business and Law. Alex is a researcher from quite a prestigious European international program, the Erasmus Mundus Joint International Doctoral Program in Law, Science and Technology. And Alex's research area is in the use of blockchain as e-governance with e-democracy as a special application. So without further ado, Alex, please. Thank you.
All right. Thank you very much for this introduction. So there are many talks about the use of the blockchain. And the thing is that there is a big gap between the talks, between the theory and the real application. It's quite a hot topic because now you've seen what's happening with the price of cryptocurrency. And the thing is that I think the speculative nature of the cryptocurrency is now exhausted. And now it's a good time to talk about the real use of the blockchain, how to use it for real-world cases. When we're talking about the efficiency of the business, we understand by that not to waste time, not to waste money, not to waste resources. And the electronic means of communication is a very good way how to make your business more efficient. And there is such thing which is electronic signature, and there is such thing which is digital signature. Before I start demonstration of some practical things, I want to explain you some basic theory about these things. I want to be sure that you understand what's going on here. So my first question to you, who knows the difference between electronic signature and digital signature? That's kind of tricky thing, you know? Any ideas?
It's a subtle difference, to be sure.
Okay, I will explain you. So I had to learn these things being a lawyer in Ukraine, in Europe. And here I found that there is a similar concept. So basically, electronic signature is a general concept that also includes digital signature. It also includes such things like you just add the string in the end of the text saying, hey, my name is John Smith, for example. And there is also, you can say that it's kind of electronic signature, so you add this kind of ugly gray scanned picture of your hard copy signature. It's still electronic signature. But being as a lawyer, I would never recommend my client to use such tools. Why? It doesn't really protect your the privacy, the integrity, your identity, and some other things. For this reason, it's better to use digital signature, which is a cryptography, which is based on asymmetric cryptography of private and public key, and there is also a hash function. I will explain you just in a couple of words these basic things. So there is a public and private key. They are connected with each other with very hairy math and strong cryptography. You use your private key to encrypt data, and then you send this data to your counterparty, to your partner. It can be like a contract, a signed contract. And then your partner will use your public key to decrypt the data. In this way, your partner will be able to verify the integrity of data and your identity. Because if he is able to use this public key to decrypt information, it means that it belongs to you. That was you who used your private key to sign this data. There is another important concept which is called hashing or hash function. It's a kind of fingerprint of data. For example, you can hash a record, a file, a message, a folder, an archive, or the whole disk, whatever, and it works like this. So we have a file, a contract. You calculated a hash sum, and probably you calculated the hash sum, and me calculated a hash sum. We all have the same hash sum of the original data. That works always like this. And if I change at least one bit information of the original data of my file, we will have completely different hash sum, a new hash sum. So in this way, we can verify the integrity of data. So for example, I lost my file, my contract, but somehow I have the hash sum of it. So I ask my partner, would you please send me again the file? When you send me this file, I calculate the hash sum and compare these two hashes. If they are equal, it means I still have the same file. There is one shortcoming of this technology. There is no reliable timestamp by default, out of box. You need some other technology to rely on. We rely on third parties. This is a traditional way. So I'm talking about public key infrastructure. You might have heard this terminology, or it is PKI. It includes timestamp authority, it includes certificate authority, it includes trusted service providers, it includes a lot of standards and some other things. So basically it means that you trust the third party that provide information of date and time when you sign this transaction. And there is another technology which is called blockchain. You don't need to trust exactly one person, exactly one entity to get this timestamp. You just trust the blockchain, the mathematics. And I will explain, it means that any kind of blockchain has its inherent feature like timestamp. And there is another thing which is very important in legal relations, identity. You have to be sure who is out there somewhere, and probably you don't even know this person who you're trying to contract in. And there are also third parties that ensure these kind of things. So they actually, what they do, you have your public key and they say, this public key belongs to this person. Because you trust me, I'm a certificate authority, you can trust this record. It's general concept, certificate authorities. There are some other things like trusted service providers, but it is the same. TCP providers are in Europe. They appeared because of this regulation which is called EIDS. You can also trust some other third parties. It's not a big deal. The thing is that, for example, there is a person who knows you, and this person knows your future partner. And he say, hey guys, I know you both, you can trust me, so you can deal with each other. There is another way how to ensure these remote legal relations, is that first you have to meet each other and so to say, exchange your public key. So here is my public key. Here's your public key. Let's make an agreement. In the future, we will trust this record because I know your public key now. And now we came to this story which is called blockchain anchoring. It is also called blockchain hashing. It is also called insertion data in the blockchain, which means that you add an information to the transaction. Transaction means you send some coins or you apply some scripts to send some coins. Fundamentally, these things are almost the same. I was just explaining you some basic things about digital signatures. And the blockchain works almost the same. So here in this story, you take your contract and apply the cryptographic function, the digital signature. And here you take both the payment data and your user data, your contract, and apply the same digital signature. The only difference here is here you have the public key, which represents your identity. And here you have not public key, but a blockchain address, which is the same. the public key, because it is retrieved from the public key. So when you use your blockchain address, it means you use your public key. And here how works the blockchain hashing. So you have your data, your file, your contract, whatever. Then you calculate a hash sum. You have your hash sum, and then you insert this data with the special transaction. It is not transaction when you send some coins from one address to another. It's a bit different. You send these coins using special script to destroy these coins. Of course, you don't destroy it in the system, but they are enacted. In this way, you ensure the immutability of this record. Why blockchain? Well, it is immutable. No one can change this record. It is permanent. It is always accessible in the blockchain. You have timestamp because all transactions are chronologically stored in blocks of data, and no one can change it. So any time you can verify when it's happened. And it is public, which means anyone can see it online. You have to carefully think. If you want this data be publicly accessible, and anyone can see your message, just literally read this. Or you just include a hash sum. It's just a fingerprint of your data. And here is the list of existing tools. I made the analysis of them, and let's say we can use any wallet. But the early, let's say, first generation of wallets like Bitcoin, classic Bitcoin wallet, wasn't purposely designed to insert data in blockchain transactions. So if you want to use Bitcoin, old version of wallets, you have to code these scripts manually. There are the second generation of wallets, like Emercoin, NAM, NXT, and dozens of these kind of wallets. So you just literally click buttons and insert your data whatever you want. And here is the list of online and mobile services you can use. They are specially designed for these purposes. So here is emernotar.io. It is web, it is mobile. They have 10 languages, and you pay only 10 cents per transaction. And you don't have to have cryptocurrency. You just pay using your bank card, actually via PayPal. It is very convenient here because it is not only a payment. It is the way you identify yourself, because you create your data, your hash sum, and then you add here the payment record, which means that if you use bank card, it means bank identified you. We trust banks, so we can trust this payment. This is a good way how to protect your authorship. Then there is another tool here to verify the record, because when you make a transaction, this is act number 1. The second act is you need to verify it. You send to your partner, you verify when you, some while. You can also use some additional information. You can type a message in the blockchain, and you can use API to develop some tools for your business. There is another thing. So this online service is based on Emercoin. This tool, Stem.io, based on 3 ledgers, Bitcoin, Ethereum, and Dash. They're quite costly, like €5 per transaction in Bitcoin, €2 in Ethereum, and 50 cents in Dash. You also use to pay your bank card. You don't need to have cryptocurrency. There is no tool for verification. You have to find something out there. And there are also other tools which I find they're not that comfortable to use, but still you can use it because, for example, Origin Stamp and Proof of Existence are free, but you have to wait 1 day because they collect all transactions and publish the bundle of transactions. But there are no tools for identification, for verification, so you have to think about how you will verify this data later. There is a block notary, which is for iPhone and it's free, but they don't have these tools. There is a notary Bitcoin.com, but you need to have some amount of Bitcoin Cash. And there are some other things which are not really reliable. I tested them, but I don't like them because they were out of service for a while. And let's have fun. I will be showing you some things how to use. All right, so let's have this service. Here is Emercoin. For example, I have a picture. Oh, let's say, do you see it? Okay. Let's say I made a picture of hurricane of the century, and I would like to sell this picture to the New York Times for $10,000. I don't know. Before I send this picture to anyone, the good way to protect your authorship, your copyrights, is to ensure the proof of existence and to connect your identity with this file. It's because when there is a dispute, for example, I send this picture to the editor of the journal, and he says, hey, I have this picture already. It means someone stolen this picture from me. And if you go to the court, the only way to prove that you are the owner is to prove that you were the first among others who own this file. That's the only way, actually, I tell you as a lawyer how to protect your copyrights. So in this way, you just drag and drop your file here. It calculates a hash sum. Here you see this hash sum. And then you sign it, which means that you send this transaction to the blockchain. And here you can choose, you can hide your email, and you just encrypt by hash function. Or you can open your email. And I can write some kind of message test. In here, I sign it. It takes a while. 10 cents. Well, actually 14 because Australian dollars. Yes. So I have to wait around actually 10 minutes, but they write 20 minutes because to be sure that new blocks are created. And then I will find a notification letter in my email box. But meanwhile, I will show you just something else. Let's say we have another scenario. There is a draft contract we agreed with the partner. I have this contract right here. Yeah. And he wrote me an email saying, hey, I just signed this contract. Would you please, it's your turn to sign. Okay, no problem. So what I see, I drag and drop this contract, this draft contract here. And the service will tell me, I found this record already in the blockchain. And here is the owner. I will explain you what does it mean. And here is the hash sum of this file. So it means it is the same file. And here is another, here is a timestamp. And here is, it's this, just an alternative explorer, blockchain explorer, where you can find the same record, this hash sum. So now, how can I be sure that this file was signed by my partner? So here is, he decided not to publish his email, he's right, but he published his hash sum. So what I do, I just open, there are quite a lot of different tools for generating hash sums. So I just use this one. I type here his email because I know his email. And here, this is a hash sum of this email. And now I need to compare these two hashes, right? Yeah, I know that he is the one who signed this contract. All right, so just a bit more theory. Meanwhile, I wait the result of the blockchain transaction. There is another interesting technology here, which is called name value storage. It is technology, it's overlay technology on top of the blockchain. It is built-in protocol. First, it was developed by Emercoin project and then significantly developed by Emercoin. What does it mean? This is a kind of database on top of the blockchain to make this record more comfortable to use, more convenient. So you store these records in a form of pairs of name and value. Name is a key. Value is something that you want to store. For example, name, I can write Alex. Value, I can write my telephone number. So this record, Alex, represents my telephone number, which is quite clear. The thing is that name is always unique. So while I have this record, while I own this record on the blockchain, nobody have the same record. Nobody can do this until it is valid or it is active, let's say. So there is a concept of lease time, which means that I set time, the period of time while this record is active. And during this time, nobody can create this record again. I can extend this time, anytime, any moment. I can delete this record, which means that you don't delete this record from the blockchain, but you send the transaction saying the system, hey, I want to stop this record, treat this record is like invalid anymore. So you just create a new record on top of the previous one. And this is a way how you can update value. For example, I change my telephone number. So I create on top of the previous record a new record saying that, hey, I have a new telephone number. That's clear. There is an important here thing that you can transfer this record from one address to another. It's like a token. So for lawyers, a good idea to think about how you can use it for contracts. For example, if this contract represents some rights, I can transfer this right. If it's, for example, a rent agreement with the right to sublease, I just can transfer this right, which means the owner now, who owns this record, has the same right. What else? Fee. You have to pay some small fee, which means that you don't send these coins to someone. You just the system applies some script to destroy these coins. And there is a function which is called atomic transaction. You can send this NVS record to someone in exchange of cryptocurrency payment. Here is the way how to, using this NVS technology, how to sign a multilateral contract. So first, you have your contract. There are parties, number 1, 2, 3. You include their blockchain addresses in the body of the text. Then you calculate a hash sum here, and you create the first NVS record. NVS record includes the hash sum of your contract. Here it is. And then when you create this record in the blockchain, you add your address because you are first who signed this transaction. And then you have to pass this transaction to the next signatory. So you create, using update tool, you add his address and you send to this guy. And then if he agrees with this contract, he sent to the next, and then you finish the circle. So in this way, we ensure that everybody signs this contract. This scheme has a very strong cryptographic protection because, let's say, we are the second party of this contract. We just got this transaction on our wallet, and we see the hash sum, and we have the draft of the contract. So we calculate the hash sum, we compare these two things, and if they're equal, it means this is the same file. And here, now I need to verify who sends me this contract. So I see that it came from address A, and this is the same address which is in the contract. And nobody actually can change this address in the contract. Why? Because if you change this address in the contract, you will have a different hash sum. If you have a different hash sum, you will be able to verify that it was changed. And this is not the only one way to use this technology. You can sign also unilateral deeds, something like irrevocable and transferable deeds. For example, a gift. So you just write a contract that I grant something to someone, and then you send this transaction. It's like a token that represents some rights. And then the owner can do whatever he wants. You can also use it for warehouse receipt. For example, I got this receipt, and I go to the warehouse and say, hey, I have this record. I send you this record, and you give me back these commodities. You can also use some revocable and non-transferable deeds, for example, like power of attorney. So you don't send this transaction to someone, you just keep on your address, so you control the time while it is valid. You can delete it in any time, but it represents some rights. So this is just a file saying, hey, I trust this lawyer, he can represent my rights, but anytime I can press the button and stop his duties. You can also use escrow and arbitrator. For example, if I showed you this circle, in the end of this circle, there can be a person who is arbitrator. We decided to use his services. So if he have disputes, we can ask him. He owns this record, and he can make any kind of, he can invalidate, delete, make some records on top of that. And finally, he will can decide how to resolve the dispute. You can also use a scheme for notary public or trust service providers. It works like this. So, as I explained you, there can be a person between you and your future partner. So you issue your record, for example, Alex. Then you ask someone third in this story, hey, would you please certify my identity? He creates a new record saying, I know this Alex, I know this record, and he put this reference to this record. And then if I want to certify in my next record that there is someone who knows me and you trust him, I just make a cross-reference to this record, hey, saying like, hey, look at this record. If you trust this person, he says, you can trust my record, my identity, and using my identity, my blockchain address, I can assign any kind of a transaction, and you will be sure that it was me who did it. You can use the thing which is called Emernic, which means that you can use an NVS record as a reference for payment, which means that I can create my record, which is Alex, and instead of using the blockchain address, you just write Alex, send money to Alex, which is very useful. You can search in your wallet, and you can use some alternative things like Explorer, Online Explorer, which is very useful. Let's summarize what we have. There is a concept, existing concept of paper contracts and electronic, like plain files. And there is a kind of smarter way to do the contract, which means that you control the time, you control terms, and it's not like just a record when it's happened, how long it is valid, like in a plain text. It's a kind of object you can control and you can manage it. So you can transfer rights. The same, here is just a plain text saying that you have this right. But here you can manage this right to just literally send to someone else. And you can interact with each other, like I've just explained you the way how to use public notary, trusted service providers, escrows, and arbitrators. All right, so there is a manual. I created this file so you can find how to use all these things with screenshots, with explanation where to click, how to calculate the hash function, and how to verify all these things. You can download it online. And there are some references, it's two academic references about blockchain insertion, about timestamping, and about NVS technology. All right, so let's go back to the demonstration. So that was the end of my theoretical part, and let's see what we have in the result of our practice. So you have this email notification, and here you can download the certificate, which has all information about this blockchain transaction. Yeah, here it is. So there is a timestamp, there is ID, the blockchain ID transaction. Here is the owner, which is the hash of email. Here is the email of the author, and here is the hash sum of the file, and here is the name of the file. Actually, it was I notarized the slides, which I just presented you. So in that way, I have protected my copyrights. You see. So anyway, I can prove now that I was the first who owned this file. All right. So questions, please.